There we go. All righty. Now I'm going to go ahead and make Dick the host. And you can go ahead, Dick, and share your screen and bring up your slideshow. Thanks for joining us tonight, everybody. Much appreciated.
Where do I share the screen?
Okay, on the bottom, if you pull your cursor down, you should see a green share screen button. Hit that.
A green share screen button.
Yep, at the bottom of the screen.
No, I see an Excel. That's the only green thing I see.
Are you on the bottom of the screen?
I am. Let me screen for my wife. Not line. Help!
Yep, it's a wee bit of a challenge to find those things, but yeah, there should be a little share screen button on the bottom. Sometimes you rearrange your screen, it might be at the top too.
Have you lost your control thing here? What are you looking for?
Share screen.
Come on, let's move this up here. There it is. Okay, there we are. And you want your Goshawk poster?
Yes, please.
Oh,
Yep.
okay.
Okay.
Yep. Okay. Share. And then that should be it, right?
Okay, so
Yep, there you go.
Okay.
You're showing the next slide too, if you want to do
okay,
that.
let's swap displays here. How about that?
There you go.
Perfect.
Beautiful. All righty. Well,
Okay,
I am going to mute myself and monitor things as we go here. But let's dive into the world of Northern Goshawks. Here we go.
Is that one? No. Okay.
Okay.
Take it away, Dick.
Okay. So the title of this talk and the title of the paper would be Periodic Invasions of Northern Goshawks. And this is the same title as was used in a paper by Mueller et al. In 1977, except that their title was Periodic Invasions of Goshawks. I misspelled invasions, I see here. But the name of the bird was goshawk in those days, so the name has changed. So I was told to write a paper on this subject about 10 years ago, maybe 12 years ago now, by Juvenile. And the co-authors are people who were starting in 1972, were banders for 51 years and were counters for 40 years. And Jan Green wanted to be the junior author, although she's not very junior. And she started counting in, or at least she counted in 1962, which was when we had the first big clear goshawk invasions. And I'm a frequent visitor to Hawk Ridge, and I first visited in the second year of the count, that is in 1952. And what I plan to do is talk about goshawks. It's the invasions of goshawks in eastern North America. And basically, it's our northwestern part of eastern North America, where eastern North America is defined by the 100th meridian. And I'm going to say a little bit about goshawks in general. Most of what I'm going to do is talk about the migrations. First, I'll show you a picture of what's happened over a long period of time at several counts. And then what I want to do is talk about particular counts at Hawk Mountain, which was maybe the best known hawk count site. And in a sense, it's the oldest, if not the first. And then Cedar Grove, Wisconsin, and Hawk Ridge, Minnesota. And goshawks invade when their prey population, particularly snowshoe hares, decline. And I'll say something about the hare lynx cycle. The goshawk observations go back over 100 years, but the data on the hare lynx cycle goes back almost 300 years. Now, the northern goshawk is the fourth most studied hawk. I'm going to call them hawks after the bald eagle, peregrine falcon, and golden eagle. And goshawks are well known in part because they have a very wide distribution. That is, they're all over North America, Europe, and Asia in the north. And they have a history of use in falconry. And there are two, I think, really interesting books, one by T.H. White called The Goshawk, and then one by Helen McDonald called H is for Hawk. Years ago, I'd sit on committees. I was a statistics representative on committees of biology students. And one thing that the students were asked was for the taxonomy of their organism. Linnaeus had seven levels of classification: kingdom, phylum, class, order, family, genus, and species. And the bird we're talking about is an animal. It's a chordate. Chordates are very roughly vertebrates, but not quite. They're birds, and their order is Accipiformes. The family is Acciptridae, and their genus and species are Accipiter gentilis. And here I've included subfamily and subspecies. I'm not particularly interested in the subfamily of goshawks, but I am interested in the subspecies of some of our other hawks. Linnaeus, in his classification, had a number of falcons, and three of the falcons were a northern goshawk, the bald eagle, and the peregrine. And peregrine is still a falcon. There are at Hawk Ridge, there are 14 birds that we see in numbers every year, usually 100 or more. There are 3 buteos, 3 accipiters, 3 falcons. That's 9, and then 5 others. And they're connected in different ways. So the buteos, the accipiters, and the falcons are all in the same genus. But the buteos, the bald eagles, and the golden eagles are not in the same genus, but they're in the same subfamily. And the accipiters and the harrier are not in the same subfamily, but they're in the same family. So the buteos, the accipiters, and the eagles, the harrier are all in the same family. Ospreys and turkey vultures are not in the same family, but they're in the same order. And falcons are not even in the same order. So what is that? What a falcon have to do with buteos? The answer is they're birds. Our goshawk, the northern goshawk, has 9 or 10 subspecies, and I think there are 4 major subspecies. Ours is Accipiter gentilis atricapillus, and the name atricapillus maybe is familiar. That's the name. That's the black-capped chickadee. Is the species name is atricapillus. So you could say that our goshawk is the gentleman's hawk with a black cap. Now, as we go from west to east, the birds get lighter. I showed Frank Nicoletti this picture, and he could see that this isn't our goshawk. It doesn't have the black head; it has a gray head. So this is the goshawk in Western Europe, and particularly Germany. They like to eat pheasants, and so here is a goshawk on a pheasant. Then going further east, in Eastern Europe, you have Accipiter gentilis buteoides, and this is the largest one. This is a buteo-like goshawk. This is a young bird. And then finally, when we get to Siberia, you have Accipiter gentilis albetus, and albetus means white. So as you go from west to east, the birds get lighter. And the idea is, one idea, an ecological idea, is that birds that live in wetter places are darker. Now, where the goshawks live, here there are range maps of birds, and this is, as far as I know, the first book that had a range map was the Robbins, the Birds of North America paperback. This is not the first edition of Robbins. And what you see is that the goshawks are spread over Canada, all the way across Canada, and then down in the Rockies and maybe in the mountains in the east. But also the thing I want to point out here is that if you look at the birds in Canada, the color is red. That is, this means that they are summer residents. Now here's another picture. And this is in Sibley's book, his Eastern Guide. And we see, as you're talking about the same bird, the map is quite different. In particular, you see some sort of a peach color around Hudson Bay. So these are the birds that are summer residents. But over most of Canada, it looks like they're now permanent residents rather than summer residents. So this is, I think, an interesting point if you look at range maps. So goshawks are partial migrants, at least they've been referred to as partial migrants. And partial migrant means that some, but not all the population migrates every year. In particular, the young birds or young males migrate, at least some of them migrate every year. Goshawks also facultative migrants. That is, whether they migrate depends on conditions. In a good year, in a bad year, most of them migrate, and in a good year, most of them do not migrate. And goshawks have a very wide variety of food, and one of the things that's studied very much in goshawks, in fact, if you're looking at goshawk research, it seems to me that a large fraction of it is you find a nest and you make a blind and you watch it and see what food is delivered to the young. So there's a lot of information about the summer diet of goshawks. But there's an assertion that very little is known or nothing is known about the goshawk winter diet, but that's because this is written by recent people. But in 1927 or 1926, there was an invasion of goshawks in Pennsylvania, and lots of birds were shot and the stomachs were looked at. And what's found was that you have about 20% poultry, 30% game birds, 30% game mammals, and other is 20%. So you could say that if you look at winter prey, goshawks are pests. Goshawks are eating domestic animals or game animals. There was another invasion 10 years later, and here there's more detail. So domestic fowl was about 30%, rough grouse 25%, and then cottontails and gray squirrels were about 25% together. Now the cottontail rabbit and the gray squirrel were the game animals. So it seemed to me that if you're worrying about they're destroying game animals, it's not something that people would worry about very much anymore. But certainly you could say the diet of a goshawk is a justification for shooting goshawks. Of course, they found that there was a bounty on goshawks starting in 1929 in Pennsylvania, $5 a bird. $5 was a lot of money during the Depression. So here is a picture of the big picture of goshawks. And so what I've done is I've marked the years in which you have goshawk invasions. This is a paper in a book on Australian, it was a conference in Australia in 2000 on owls. And the great horned owl and the Northern Goshawk basically have invasions at the same time. So I have the pictures of the Goshawk data rather than the great horned owl data. The great horned owls had invasions at the same time, except for in the 40s and 50s, when they didn't have invasions. The Goshawks did, but the Goshawk invasion looked like it only lasted for 1 year. So what this does is it shows when there were invasions, but it doesn't show how big the invasions were, although you could say that the ones in the 40s and 50s were small. The ones in the 20s and maybe in the 70s and 80s looked like they're 3 years, so they were longer. Now the data from this, at least a lot of the data come from books and monographs that include goshawks as examples of species. And one of them is Birds of Minnesota by T.S. Roberts and Arthur Cleveland Bent on his life histories of North American birds. And the Bent book has a bunch of the years that Newton used. And then Heinzelman has data from hawk counts up through about 1972. And then I think of the monograph about North American goshawks as the one by Squires and Reynolds in 1997. And that has more count data, including data from Hawk Ridge. And then there are works by two British writers. One of them I mentioned, Ian Newton. He wrote a book called Population Ecology Raptors in 1979, and then he had a volume that had the chapter including goshawks in 2002. And then Kenward has a book called The Goshawk, published in 2006. So there's a lot of information, and the picture that I showed was from Ian Newton. An early paper was by Ruth Van Dien, and this is a paper based on observations made by taxidermists. And Ruth Van Dien grew up around Cambridge, Massachusetts, after the Civil War, and he had some friends who were serious fellow birders. And the only one who became an ornithologist was William Brewster, who might be a familiar name to ornithologists. And another name, which is familiar maybe because of the father, Richard Henry Dana III, was a lawyer, but his father was a best-selling author, and he married the daughter of Longfellow, so we could say both he and his wife were descendants of famous writers. Daniel Chester French is someone whose work is familiar to everybody. He did the sculpture of Abraham Lincoln in the Lincoln Memorial. And then one more paper, this is from Murray Spires, and when he was 15 years old, he started keeping track of every bird that he saw every day, and he kept on doing this for 75 years. But before he did that, so he was in Toronto, and the Royal Ontario Museum collected birders' lists. So what he did is he took his own list and the list of other bird watchers, and then he looked at variability in a number of species, including great horned owls and northern goshawks. And so this is one of the sources of information. So where does the information come from? Well, you had taxidermist records, and so you have someone who happens to be friends with lots of taxidermists. You have bird watchers and their daily lists, and then starting in the 1930s, you have systematic counts, and then later on you have banding observations as well. So the oldest, I think, the hawk count was at Hawk Mountain. It's a Hawk Mountain sanctuary. They were shooting birds there in the late 20s and the early 30s. Rosalie Edge was a founder. She was a society lady and a conservationist. And she had a mentor, William Gibbs Van Neem. He was someone who showed her the birds and interested her in conservation. He grew up in a household that included his uncle, whom Albert Einstein referred to as the greatest mind in American history. So Willard Gibbs is the name of a famous scientist, and Van Neem shares the name with his uncle. And then Rosalie Edge recruited Maurice Brown as a counter and the first curator of Hot Mountain. And Irma Brown was a new bride. She was the keeper of the gate. So she was a feisty little woman who told the armed men who came to shoot hawks that they couldn't do it anymore. This was now a sanctuary. There's, I think, a very nice book about Rosalie Edge and the history by Hannah Fermansky. So here are the data from Hawk Mountain, and I think if you look at this, maybe you have trouble seeing peaks. There's certainly a peak in the 30s, the highest value in 1935, high values in 35 and 36. The counter was at war in 1943, 44, and 45, but I can use the data for the birds returned for bounty in Pennsylvania. So what I've done is interpolated those data when the counter was gone. And that makes it look like there was a peak, maybe not sort of high peak, in 1945. There was a very big peak in the 70s. And then in the 80s, there are 3 big years together, well, not as high as the 70s. But it looks like, let's say it's hard to see a 10-year cycle in these data. And in fact, the second curator was Alexander Nagy, and he published a picture, basically this picture. And so his point was that there's not a 10-year cycle, there was a 4-year cycle. And in Ian Newton's book in the 1979 book, he refers to both the 10-year cycle and the 4-year cycle. Then in Cedar Grove, Wisconsin, there was a large flight of hawks observed in 1921. There are people from the Milwaukee Public Museum that banded birds at Cedar Grove, which is 40 miles north of Milwaukee. And then a banding operation was started in 1936, but the banding operation lapsed. And then it was resumed by Helmut Mueller and Daniel Berger in 1950. And they really didn't know what they were doing, so they didn't band very many birds, and they lost their data for the first year. But they figured out what they were doing, and from 1951 on, they counted and banded birds. And they did this, they wrote a paper on their first 60 years. But anyway, they wrote a paper on the 60 years of observations. Now these are data, and this looks like it's showing something in the 70s and the 80s and the 90s. It looks like they're peaks. There was a peak in the 70s, and in 1977 they wrote a paper that I mentioned, and I think this is a very useful paper. Maybe it's the best known paper on the population migration, population invasions in North America. But they made a mistake in predicting that the invasion in the 70s was so big that the animals would not be able to recover by the 80s, that there wouldn't be an invasion in the 80s. And in fact, they saw more birds in 1982 than they had seen in 1972. And in fact, it was in 1982 that I got interested in this problem. I went up to Hawk Ridge after school one day. Goshawks were coming by like crazy. It turned out that in that one day, this was October 15th, 1982, there were twice as many goshawks seen as had been seen in the 24 years that Mueller and Berger, allies, used to predict that there wasn't going to be invasion. So they had been publishing papers in the AUK, and it seemed to me they had trouble publishing papers for a while after that, because they I think had quite a clear statement, and the statement was wrong. Now at Hawk Ridge, the Hawk count started in 1951. Hawk Ridge got its name, and the Duluth Hawk count became continuous through October in 1972. And then the Duluth Hawk count was extended through November in 1993. So I think of the Duluth Hawk count as basically having 3 periods, 3 20-year periods up to 10 years ago. One of them was the first 10 years or 20 years in which they had sort of occasional counts every year, but not for a whole year. That was made systematic, but it did include November for 20 years. And then it included November. And this corresponded to Frank Nicoletti. Frank Nicoletti came in 1991, and he counted a little bit in November then, and then more in 1992, and then for the full month in 1993. So the Duluth Bird Club was founded by 2 women at the Blue State Teachers College, now UMD, 1937. And 2 of the early members were Catherine Liskey and Evelyn Palmer, who taught at Lakeside School in the 1950s. And Catherine Liskey was my 3rd grade teacher. And more important, maybe 3 years later, she was my cousin's teacher. And at this time, the Hawk count had started. So I went with my cousins, Bill and Bob Olving, starting in 1952. Jack Hoss and Joe Brunel and Ole Vincent were bird watching companions who helped stop the shooting. They were shooting in Duluth, but they stopped the shooting before they started the count, unlike at Hawk Mountain. So there were not maybe great observations in the 50s and 60s, but there were say substantial invasions and observations in 1962 and 1963. And so what I've done here is in red, I've shown the number of birds seen, but also I've inflated the numbers by showing how many birds would have been seen if the count went every day. So then here, what I've done is I put in all the data, so the early data and the late data. And what you see is certainly in the 70s and the 80s, there were really big peaks. In the 90s, there was something, and maybe unlike Cedar Grove, looks like there was something in the aughts, so 2000, 2001. But there hasn't been anything since. Also, if you look at the inflated numbers, it looks like there's something in the 60s. So there's something in the 60s, big invasions in the 70s and 80s, something in the 90s, and maybe a trace in the aughts. But a trace is still 1,000, which is more birds than they're seeing anyplace else. I think that this is a nice picture, a nice thing to look at in detail. So this is an invasion, but I think also maybe my paradigm invasion, this invasion in the 80s. And what you see here is the blue is the young birds, the juveniles. And before the invasion, you have the blue numbers increasing. That is that maybe things are getting more and more crowded. Maybe conditions aren't getting so good. Some more young birds are leaving. Then when you get to 82 and 83, there are very few blue. That is, there's very few juveniles, which I think means the bad reproduction. And now the red ones are the ones that are 2 years old or older. And there are huge numbers of those in 70 and 82 and 83. And the black ones are the ones who are 1 year old. That is that they're the 2nd year birds. And what you see is that there's in 81, 82, but there's nothing in 83 and 84. And the reason is that there were very few juveniles in 82 and 83. And so the next years, there'd be very few adults. And then what you see is after you get past the invasion, you're only seeing juveniles again. So what happens for goshawks is that you see juveniles in non-invasion years, and then at least in the big invasion here in the 80s, you have very bad reproduction. And here are the numbers, say for all years for which you have good banding data starting in 72. And the red and the black are the adults, the blue ones are juveniles. You should never in the population have more than half the population be juveniles. And what you see is at least a lot of the time you have almost all of them juveniles. But what you see is at 72, 73, and at 82, 83, they're almost all adults. So there are very few juveniles. So there was very bad reproduction. And here is a comparison so that they banded the birds at Cedar Grove. They got so few between invasions that they grouped them all together. But what you see here is that the blue represents the proportion of the birds that are juveniles that are banded. And what you see is that at Hawk Ridge, the proportion of juveniles in 82, 83 less than in Cedar Grove, and 82 and 83, also in 92 and 93, and in between, the years in between. So what this says is that there are always more juveniles, a higher proportion of juveniles banded at Cedar Grove than at Hawk Ridge. But in my last picture, I have the totals, and for the totals, what you have is more juveniles banded at Hawk Ridge. So you always have more juveniles banded at Cedar Grove, but overall, you have more juveniles banded at Duluth. And this is an example of Simpson's paradox. And so like you can lose all the battles and win the war. Now, here's something that we have in Duluth that we don't have at Cedar Grove. This is the age distribution of the birds that are observed. So this is when Frank Nicoletti came, he started trying to identify each bird that he counted by age. So here you can't discriminate between the second year birds and after second year birds, that is the adults, but you can discriminate between the juveniles and adults. And what you see here is that in the 90s and in the aughts, you had a high proportion of adults, and then you have a higher proportion of juveniles in the non-invasion years. Now, something that I like about this is if I look from 2006 on, I have for 2006, 2007, I have a small proportion of adults. Then I have a high proportion for 2 years, and then a low proportion for 2 years. And then a high proportion for 2 years, and a low proportion for 2 years. So the chance of getting a pattern like that is something like 1/210. And so what this suggests to me is that the age distribution looks like there is 2, 2, 2, 2, 2, 2, and so on. And if you look back at earlier years, you'd see a similar pattern. And so the suggestion is, this is evidence of a 4-year cycle in the fluctuation of goshawks. But here I'm not looking at the numbers, I'm looking at the age distribution. But of course, the age distribution is connected with the numbers. And here I'm comparing the bandability, and Mueller and Berger thought that maybe the young birds were easier to trap than the older birds. And then later on, they observed that the trapability is about the same throughout the season. And so they concluded that there wasn't any difference. But here at Hawk Ridge, we look at the number of birds, so the proportion of adults banded and the proportion of juveniles. And what you see is that in many years, you have about twice as many juveniles banded as adults. where proportion is about twice as much. So in fact, if we use the banding data for the age distribution, we certainly have bias. Now for the age, for the sex ratios, the hatching year birds at Cedar Grove, the sex ratio was exactly 2 to 1 for hatching year birds, and for second year birds it was 1 to 1. At Hawk Ridge, it's almost 3 to 1 for young birds. It's male biased for the second year birds. It's female biased for the older birds. And here's something that I was amused by. That, in fact, presented a paper at an International Ornithological Congress in 1986. And looking at this data from the 70s and 80s, and I was particularly interested in this. If I look at the older birds, the sex ratio in 1972 was 1 to 1, but it was female biased the next year. In 1982, it was male biased the first year and female biased the next year. And so I thought, oh, what's going on? Is the sex ratio changing from year to year during invasions? And so I tried to explain that. Unfortunately, if I looked in the 90s, what I see is that here you have female bias sex ratio both years, and there isn't much difference. And in the aughts, I have very smaller values, and basically the ratio is 1 to 1. So this is one of these examples you see as sort of maybe a nice picture, and then you look at more data and you say, okay, well, it's not so nice. So goshawks come when the hare population goes down, and Hudson Bay Company had records for a long time. And here's a nice picture. This is from Encyclopedia Britannica, but this is Hudson Bay data. And what you see is that there's certainly a relationship between the snowshoe hares and the lynx. And here is a figure. So the Hudson Bay data goes up in the 20s, and here Statistics Canada, or what's now called Statistics Canada, started in 1919. And so here you have data, but here it's by province. And what you see, that these are lynx data. What you see is in the 20s and 30s, it looks like they're pretty nice regular peaks. And then in the later years, in the 60s, 70s, and 80s, it looks like there's a nice peak. But then in the 40s and 50s, you're not seeing very much. But that's just what we saw with goshawks. That is to see, it looked like there were maybe some there were big invasions in the 20s and 30s. There were invasions in the 70s, 80s, maybe something in the 60s, and there wasn't much in between. So here is sort of a connection maybe between the hare lynx cycle and the goshawks. And my last picture, which I guess doesn't show here, is the data from Plenty, in which we have the biggest invasion in the 80s and then lower invasions in the 90s. And so what might be happening is that we just don't have the big hare lynx cycle that we had before. Okay, that's it.
All righty. Well, thank you, Dick. We do have a question. The vertical axis in your first graph of the invasion graph, what was your what's the vertical axis quantity, or what does it represent? I'm assuming it's numbers, but yeah.
Which one was it?
The very first graph, when you were talking about invasion years and the different periods of time where there were invasions.
Well, the first graph is, I mean, the first one was just a bar representing the fact that there were invasions that year. Is that what you mean?
Yeah, that's the one.
Yeah.
So there wasn't a vertical value?
No, so I made that.
Okay.
So it was a table. So in fact, what it was is a table for great horned owls and goshawks.
Okay.
And
Okie
so what I
dokie.
did is I just made basically they're just marks telling you what years they're invasions. So in fact, that's one of the kinds of information is when are their invasions, and then you have the numbers, and then you have the age distribution and the sex ratios.
Interesting. All right, folks, this is a good time to chime in with questions. I know I've got a couple. Anybody else want to chime in? I got nothing else in the chat. Okay, so this person says, so the cycles can possibly be explained by hatchier birds being less skilled hunters. They must migrate, and after hatchier numbers only increase when the food is really poor. Is that a valid conclusion?
Yeah, the idea I think is that the younger birds are not as good at foraging, and so they're more likely to leave. So if things aren't great, then they're likely to leave, but maybe they're getting winter and they don't like winter, so they might leave. But the numbers of the juveniles that you see aren't that great. So basically, if things are good, I shouldn't say nobody leaves, but not very many leave, and the ones that leave are the juveniles. So that's one point. And then another point is that of the juveniles, they're mostly males. And so there was, I think, a nice idea of a distinction between survival selection and reproductive selection. And what happens during reproduction for this goshawks and most hawks is the females sit on the nest and the males bring food. Now there's probably more small food than large food. The males are smaller. There's a lot of food and the males have to find food fast. So the males are selected for being able to find food fast. They're selected for reproductive, reproduction. Basically, well, they have to eat themselves, but they're helping their mates. On the other hand, the females are larger, and so they can take larger prey. And so the idea is that you might be clumsier at handling the prey, but there are more prey you can have. So when things are bad, then if you can take more prey, you're better off. And so the females are selected for survival. That is, that they can survive when things are bad, and the males are selected to be able to get food fast. So that's sort of an explanation. It's the inexperience of the young ones that have them leave, but also there's a sex difference, which might be due to the size of the bird and the quantity of prey, the kind of prey that you're getting.
Yeah, interesting. I always think about that hatchier as being partly dispersal and partly unskilled hunting. I mean, they are being told you got to go find your own habitat. So
well, so that's another idea, which is here I like to think about it in terms of food and good years and bad years. But what happens is that so you have an invasion. There's not very much food. There's bad reproduction. There are not very many goshawks. But then the goshawks start reproducing. The populations increase. But it's the same true for great horned owls. So great horned owls don't do very well if there are no hares around. So what happens is both the goshawks and the great horned owls are increasing in population. But when they get crowded, especially if they start reducing the prey, then there's more hostility. In particular, females can drive the males out. That is, if the females are socially dominant. But also the great horned owls are more likely to be attacking goshawks if they're intolerant of competitors. So in fact, the great horned owls do kill goshawks, but they're much more likely to kill them sort of late in the cycle, that is before before a crash, but when the population, both of the owls and the goshawks are high, and then the prey population is starting to go down. So quite a bit is known about the system.
Cool.
Well, also so my idea is that the system has, I think of being 6 species. So you have the prey are the hares and grouse. Oh, grouse is not just, well, the grouse are several species. And then you have the lynx and coyotes are mammal predators, and then you have the goshawks and the great horned owls. And one idea was, so my wife was visiting the Yukon in 1982, and she was told that the lynx were coming in. So that's an interesting idea, that the lynx populations increased, and then that could affect the population. So the lynx basically are obligate predators. They have to prey on the hares, but the coyotes are more variable, so they have variable diet. So of course they're happy if they can eat hares, but if there are not very many hares, they can eat some other things. And so one idea is that there was a change in the system. You had an increase in the number of coyotes. And in the south, in northern Wisconsin, coyotes are the major predator of the snowshoe hares.
Interesting. So yeah, talk to us a little bit about 4-year versus 10-year cycle. And in the East, it looks like it's a fairly consistent 4-year cycle. Cedar Grove sort of in the middle, and then if what you say is right about Hawk Ridge, we're back on the more towards the 4-year cycle. Any idea what might be causing that variation in the distributions geographically?
Well, so the idea is that the cycle is determined by the prey. So the hare cycle, the hare lynx cycle, is a 10-year cycle. In the tundra, there's a 4-year cycle. That is, the lemmings have a 4-year cycle, and they're foxes. So they're the foxes that have foxes, but they have a 4-year cycle in the tundra, and then they have a 10-year cycle in the boreal forest, where they're part of the system. So my idea is that the 10-year cycle is dominant, and maybe should be dominant. But well, there were no at Cedar Grove, I'm sorry, at Hawk Mountain, it looks like there weren't big invasions. There weren't the 10-year cycles in the 40s and 50s, maybe in the 60s. So, okay, so the 10-year cycle isn't there. So maybe there's the 4-year cycle. In the same way with DULUTH, you have the 10-year cycle, but the 10-year cycle got, well, there were huge peaks in the 70s and 80s. It was clearly a peak in the 90s, but then in the aughts, it looked like there was something different. In fact, looked like there was something went over a 5-year period, but maybe with something lower in between. So maybe it's breaking up into a 4-year cycle. But then certainly after that, it looked like there's a 4-year cycle. Now there's a very nice book by, or very nice article by Scott Weidensaul in Living Bird about our goshawks. But then he also talks about 4-year cycle. So Dave Brinker has some evidence about the 4-year cycle in the East. And the idea is that, the important prey for those are chipmunks and squirrels. And the chipmunks and squirrels have a 4-year cycle. So the idea is that maybe there's a switch in prey, and the different prey have different cycles.
Yeah, a whole lot more complicated than it appears on the surface.
Yeah.
Others, questions? Well, I have one more for you then.
Okay.
So what do we feel like should be the next steps as far as research? Where should we go from here to try and puzzle out more of this story?
Well, I think for Goshawks, but also for the other things, like Dave Schimpf did the work on the cycles of rodent eating hawks, and so certainly the thing to do would be to look at the prey. I mean, so look at the system. So I would say I have some information about the prey, but the information I have is from Rochester, Alberta, and Kluane Lake in the Yukon. Well, and then I have the data. We have the data from Hawk Ridge. Well, we're not seeing our goshawks are probably coming from Manitoba and Saskatchewan, once in a while from Alberta, but not very often. Not very likely to be coming from Yukon. So we're seeing birds. They're coming from someplace else, but nobody's looking at the system there. So if you want to. So I want to tell a story, but I can say, oh, the story is we're looking at goshawks coming through Duluth, and then we had in the 60s and 70s there was a study in Alberta, and then from the 70s on, people are doing stuff in the Yukon. So. So it seemed to me that, and then what you want to do also is maybe you can look at what's going on in the forest. And so certainly one idea is that, so what are the goshawks doing? So my idea is that the peaks aren't big enough to make them want to leave. So that's a possibility, but it could be that they're leaving, but they're not coming all the way because they're finding good places to stop along the way. And we know that some birds do that some birds, like the owls, you have something that migrates, they might be obligate migrants that just want to migrate. Other ones are facultative migrants, they go until they find something. So it could be that what happened is that the goshawks used to more or less blindly, things are bad, and so we're gonna migrate 1,000 miles. And now maybe they don't do that. They say, well, things are sort of bad, but I bet we're going to find something in 100 or 200 miles. Well, so it's possible, and it might be possible to find that out. But what it would require is looking at or trying to look at what's going on in the other places.
Right. Yep. So we've got another question that, okay, so from another audience member, the obvious question, when will we see the next big numbers of goshawks at Hawk Ridge?
Yeah. No. So one of I don't know if this is a conclusion. I mean, certainly I've been thinking, I know Frank would like to see them, and we certainly hope that we see them. But I think one thing you can say is that we observed something. We had these huge invasions in the 70s and 80s. Okay, and that's a fact. And we can describe what was going on then. And we also had something in the 60s and 90s. And it could be that we'll never see them again. But what we do have is what we observed. And we can try to understand it. But it seems to me that the way I would describe it is we had really big peaks in the 70s and 80s, but then you had a decline. You went from almost 6,000 to 2,000 between the 80s and the 90s. And then you went from 2,000 to 1,000 between the 90s and the aughts. But then we haven't been above about 300 since then. And then the last 2 years, if you look at the counts, if you look at composite numbers, which I prefer, we never had fewer than 100 goshawks until 2 years ago. Then we had 96, and then last year we had 64. So my idea is we had a decline from huge peaks to moderate peaks to small peaks to maybe no peaks, but still 200 or 300. And then the last 2 years we didn't see anything. So I don't know what's going on. I mean, whether they're so the answer is I don't know what the answer is.
Yeah.
But I would
Well,
certainly like to see it have another big invasion.
certainly,
Could be that-
and we hope so.
Yeah, but we need. I mean, what you had for the big invasions was you had I think a real crash in the prey population, and very bad reproduction for goshawks, and the reproduction is probably worse, but it's still maybe it's worse than it should be. But the reproduction looks much better, certainly than it was in when we had the peak invasions. So certainly that's so. You're not seeing the birds, but you're still seeing the age distribution. So I can look at the numbers for the. I can say, okay, here's a peak, but I can also look at the age distribution. And what happened was year before last and the year before that, we had high numbers of adults. 2 years ago, we were in a usually high number of adults. And then this last year, there were very few adults. So I would expect a small number of adults again next year. So certainly that's one thing to look at. If you're looking at lots of birds, you say looking for lots of birds, maybe you don't see them. But it could be that you're still seeing something in terms of reproduction. And also, I think that's probably something too, when you can identify the age distribution, that's a good thing to look at. So that you're looking at fluctuations of populations, but you can also look at the fluctuations of the age distribution. So if population is down, why is it down? Is it down because you have bad reproduction? And if you're looking at the age distribution and you're seeing everybody, then that's another way to look at the hawks.
Complicated story, very complicated.
Yeah, oh yeah.
Anybody else out there with questions? Alrighty then. Well, thanks so much for coming out, folks. I'm gonna